Hi guys, welcome to your last set of notes for all of 2016. We're still talking about acids and bases, but today we're going to talk about neutralization reactions. And we mentioned this yesterday, but a neutralization reaction is when you combine an acid and a base. And when you combine them, it always produces a salt which is an ionic compound, and water. So any salt that we have, ionic, remember, means you have a positive and a negative put together, and then water is H2O. So stop and think about what you know about acids. Remember, acids have an extra hydrogen, and bases have a hydroxide, and if we combine HOH, we end up with water, or H2O. So that's where the water part comes from. The salt comes from the other stuff hooked up with it. So like if this was hydrochloric acid and sodium hydroxide, the chlorine and the sodium are going to hook up and make your salt. So one thing that makes this a little confusing is we use this word salt in everyday life, but in science it doesn't necessarily mean table salt. Salt is just a compound formed from negative acid ions, so like the chlorine in our last example, and positive base ions, so like the sodium. Now this one, when you combine, does make sodium chloride, which is like your actual table salt, but it doesn't have to. If we were to combine one other acid and one other base, it won't always make sodium chloride. So get the definition of salt from everyday life out of your head and start to think about it as an ionic compound. So here are some common salts. Obviously our table salt is going to be on here, but there's a few other ones that you might know. Baking soda, you guys have all played around with that. Have you ever mixed baking soda and vinegar together, like to make a volcano? When you do that, you end up mixing a base and an acid. It forms a reaction, and you get this salt out. Calcium carbonate, potassium nitrate, potassium carbonate, sodium phosphate, and ammonium chloride are all examples of salts. But for each one of these things, you can go through and you can say, here was a positive, here is a negative, a positive, a negative, positive, negative, positive, negative, positive, negative. So remember, salts are just ionic compounds. They got the positive part from their acid, and they got the negative part from their base. So, every neutralization reaction looks exactly like this. You have an acid plus a base. They're going to neutralize. You always get out two things. You always get out salt and water. So remember how we did those reaction predictions before, and then you had some on your test where if you knew it was a combustion reaction, you knew you got out water and carbon dioxide, or if it was decomposition, you knew you started with one thing and it broke off into two. A neutralization reaction is exactly the same thing. If you add an acid plus a base, you always get out a salt and water. So I know I've used this example a ton, but let's say I combine hydrochloric acid and sodium hydroxide. This and this are going to hook up to form water, your HOH. And then this guy, your chlorine, and your sodium are going to hook up to form your salt. And that happens every single time. So let's take a look at one we're not as familiar with. Maybe. KOH, so potassium hydroxide, NHO3, this is nitric acid, gives us water and potassium nitrate. So, which one's the acid, which one's the base, and which one's the salt? Obviously we know this is water, so we don't need to bother labeling him. Your acid and your base are always going to be on the left side. Remember, the stuff on the left side is called your reactants. Your salt is always going to be a product. And this is going to be on the right. So that makes it very easy to identify what the salt is. It has to be this guy right here. Oh geez, what happened? has to be this guy on the end here, KNO3. Now if we look over here, remember your key to deciphering if something's an acid or a base is look for the OH. That's going to tell you that it's a base. Look for an H being added to something. That's going to tell you it's an acid. So in this case, the HNO3 is your acid. The KOH is your base, which leaves KNO3 as your salt. So some of the questions I'm going to give you about this stuff tomorrow is I'll just list a bunch of these things and you'll have to tell me if it's an acid, a base, or a salt. And then we're also going to do these reactions and make predictions. So I'll give you the acid and the base and you got to tell me what we should get out. If you have any questions, please make sure you write them down and I can answer them on Thursday. If not, have a good night.